drive past the building and see solar panels on the roof, but how do we actually decide how many solar panels go on the roof, which inverter to use, and whether you need a battery or not? Today, I thought I'd show you our process and the way that we do it. Cool, so step one is finding out about how much energy you're using it as a business or as a home at the moment, what tariff you're on, how much you're paying for every kilowatt hour worth of energy is coming into your building. It's most importantly when you're actually using that power. This is a standard business electricity bill from Octopus Energy, and it shows that in the month of November 24 to the 31st of December, we use 3,500 kilowatt hours at an average of 24.66 pence per kilowatt hour. We then go through a consultation, find out why the business is using that much. And we'll then move on to find out exactly what time of the day that power has actually been used. It's all about understanding exactly what you're using, when you're using it, and why you're using it as well. We then move on to our design software. I'm going to show you something on OpenSolar, which is our preferred method for medium commercial and residential. So we've input all your details. We'll then move over to the energy tab, which allows us to determine exactly how the business is using their energy. For this business, which is our business, our estimated annual usage is 23,588 kilowatt hours per year. I'll configure the usage profile and I'll actually tell the system when we're using that power. So I've told it we're using 23,588 kilowatt hours per year, but that's not an even split per hour, 365 days a year, and that'll be split based on when we're actually using it. Weekday usage, business hours 9 to 5, and then weekend use is flat. So we don't use it at all. It then allows me to tell the system exactly how much power we're using on a weekend relative to the weekday. If you're not working weekends, you'll often find that the usage of a business will be almost nothing, which is a really compelling reason for most businesses to have battery storage, because it means that the sun's out on the weekend, you can spend all weekend filling up your batteries, so when you get back into the business on a Monday morning, your batteries are full and ready to power your building. And that's how we program in exactly what electricity you're using. Off the back of that, we will then size a solar array. So we'll go and we'll find out from your perspective, is your objective to mitigate 100% of your electricity bill? If yes, is that realistic? Have you got a big enough roof space to do that? Is your objective to decarbonise for purposes of public tender? So do you want to have a decarbonisation strategy so you can sell into public sector, as an example? Are you focused on return on investment period? So are you focused on having the optimal system for the shortest amount of payback? Let's pop a building in here. So I'll build one manually so you can see if you had a decent sized roof in our location, what exactly that would look like. 9 times out of 10, you get a roof, it's not this simple. There are boiler flues, there's Velux windows, there's cables going over the top, etc. For demonstration purposes, again, we will just simply show you a really, really nice, easy design. I choose which panels I want to put on. Now that's dependent on the size of the roof, but generally speaking, we try and go 500 watts for a commercial roof. We only go for tier 1 solar panels with really, really long 25-year performance guarantees on them. At this stage is the fun bit. We then start pasting panels all over your roof. Step 1 for us is to see how many we could theoretically put on. For commercial roofs, you have to have a spacing around the panels of exactly 1 metre at the very minimum. For a residential roof, you've got 40 centimetres. Really clever bit of software here. You can see up here that it's just automatically populated. That's a 50 panel system. But most importantly, it's already showed us if you have those panels facing southwest, which this building's facing, you would be generating 22,325 kilowatt hours per year. Now, if you remember back to our energy usage data, we're actually only using 23,588. Now, those two numbers are not mutually exclusive. So just because we're generating 22,325 doesn't mean that we're going to have no energy bills. That simply means that on any given year, the solar array will generate this. The most important thing is time of use. We know that our time of use in this building is Monday to Friday, 9 to 5, which is really good. Most of the power coming off the roof will be used, but on a weekend, you're not going to be using any of it. And in comes battery storage. So the next step is we will add in a solar power inverter, which converts the DC energy coming off the panels into usable AC current. And we will stick to brands that we know. Solax, they do an X3 Ultra 25 kilowatts. And again, we want to size the inverter at the same size as the array on the roof. And that essentially means that if we are generating 25 kilowatts off the roof, then we're not stepping down the power at all. 25 kilowatts coming off the roof. And that can all be converted into usable AC power in the building. Most importantly, we're not stepping it down. So you're never going to be limited by this setup. Next, we move on to the battery selection, and we can go on here and just have a little play to see which batteries that we could use we will always use the same brand of battery and the same brand of inverter. In this case, we're going to go for the TBAT stackable system to generate the most efficiency for you as a business. You can see grid independence and self-consumption. Starting with one 10 kilowatt hour battery, you can see that average cycles per day is 0.45, which means that the battery system will charge and discharge once every 2 days. And the reason for that is, based on what we've been through today, that our usage 9-5 Monday, Friday, and this is only going to really come into effect on a weekend where we're not using any power, which will mean that the power will be diverted. So for the demonstration purposes, I'm going to add another battery in. We'll have 20 kilowatt hours worth of battery. We plugged in your energy usage, we plugged in when you're using it, how much you're using, how much you're paying, and this is the part where we find out how long it's going to take you to get paid back. Your estimated annual bill saving first year is £5,647. The total system price, as a complete example for this, is £18,750, giving your business a return of 3 years and 1 month. So that's a 3-year return on investment. Now, it's so important you know that the panels will have a 25-year performance guarantee, sorry, a 30-year linear performance warranty on the JAs, and a 15-year product warranty. The inverters that we install have a 10-year warranty, as do the batteries have a 10-year warranty. You can see here that 95% of the energy of the business is coming from the solar. Of the energy that comes off the roof, nearly 70% of that is being used directly in the business, and 31% of that is getting exported to the grid. As you can imagine, a lot of that be on the weekends. The most important bit of information that we can show anybody is the net financial impact for you as a business. So the utility bill saving over the period of the life of 20 years for this business is £227,255. You net off the cost of the actual system itself, which means the net savings is £208,000 and some change. And it just shows you as a business here that after the first 3 years, your savings exponentially increase. Wizard Zero designs 30 to 50 commercial solar arrays on a monthly basis. What we would love to do is create a design for you, an estimate on cost and an estimate on return, so you can see how we can change empty roof space, unused roof space, into potential revenue for the business and savings for the business. Get in touch today and we'll start the design process for you.